Welcome to another video explaining the universe using the particle model. Today I'm starting a series of videos which are not typical. I'm not talking about any specific science topic except to talk more philosophically about things like laws and there's and the use of words and phrases and how they're often misused. Actually, on January 9th, just past January, David, my son, had a Saturday science chat that discussed the use of words and phrases. The title of the chat was Physical Reality versus Science Poetry. And many people throw around words and big words, and they expect the reader or the listener to understand what they're saying, but rather than explaining it, just nice, fancy words sound pretty, sounds like you know what you're talking about. Well, I intend on making a series of videos based on the use of words or phrases and show how these are often misused and exaggerated. Now, here's a list of words: law, constants, proof, real, time, space. That may not be the complete list, and I may not even cover all of these because some of them I have, but not specifically a whole video discussing the words. And there are phrases. The one that came to mind, and I hope I can come up with a few more, but in fact, I'll talk about this one today as a phrase: light obeys wave theory. Interesting statement. So what does that mean? Well, here are some laws. I looked these up in the internet. You have the law of the land. This is a collection of traditions, customs, statutes, uses, and laws of the country that apply to everyone, including the government, under the jurisdiction of courts, also referred to as the legal system. Then there's the moral law. Moral law is a set of universal rules that should apply to everyone. Ethical principles held primarily by the followers of Christianity have influenced the development of U.S. secular law. As a result, Christian moral law and secular law overlap in many situations. That's their definition. Yes, I am a Christian and I'm not pushing that point, but that is one of the bases for the moral law. Law of the land, moral law. Scientific law. In science, the term law has diverse usage in many cases. They're approximate, accurate, broad, or narrow across all fields of natural science, physics, chemistry, biology, geology, astronomy, and so on. So the laws are approximate, which means they're kind of broad statements that are not very precise, don't give you any real specifics, whereas the ones that are more accurate or more precise, like Newton's law of gravitation, they give you very specific details. Some are broad, covering all these sciences here. Some are narrow, which may only apply to physics. Laws are developed two different ways. One is from data and can be further developed through mathematics. And what a pitfall that could be. But in all cases, they are directly or indirectly based on empirical evidence. That is, what we observe or what we measure. We take our observations and our measurements and we put it together and try to make some sense out of it, come up with a statement, equation, something. These are called empirical statements, empirical laws. And laws can be developed from theory and are often considered more valid as long as you're accepting the theory. If you're accepting or agree with in any way the particle model, we could have developed laws with the particle model, which we didn't, however. And they're considered more valid because there's an apparent physical basis for it. And if you agree with the theory, then you would accept the law. But however, a theory is only a suggestion and may not represent reality. Okay. But one of the interesting things about laws is laws have consequences. Here's more of the law of the land. Speeding laws, you get a ticket, you pay a fine. Theft, petty theft, grand theft, federal grand theft, you get a fine and possible prison. Assault, you can get 1 to 10 years in prison. Murder, life in prison, even death. The laws have consequences. You might ask right now, well, does physical law have, or science laws have consequences? Man-made science laws like Newton's law, and you can tell they're man-made. You've got Gauss's law for magnetism, Faraday's law, Ampere's law, Ohm's law, Kirchhoff's laws. You go on and on. All these laws are named after people. These laws didn't come about until the people made them. Therefore, if they existed in nature, they didn't exist as a definition of a law. That's going to be my main point. These are man-made laws, and they came about only when scientists, like the ones named here, went through and by observation and by measurements and whatever they did, experiments, come up with these ideas, and they call them laws. Well, I actually went online one time and I typed in laws of nature and looked for laws of nature. I want to find a real law of nature. Can't find any. They're not there. The references I found generally talk about scientists who develop laws to help describe nature and by implication, they are describing, quote, laws of nature. That's the way we tend to interpret it. And that's what I'm saying. These statements are incorrect, they're exaggerated and misleading. My point, laws of nature do not exist. You can't find any law, theory, principle, or equation that exists in nature. And then there's Newton's universal law of gravitation, and this is one of my comments. It is not universal, and it is not a law. Dark matter is invented because Newton's law of gravitation does not work at the edge of the galaxy. That is, if you use it the way Newton prescribes to use it. So you take the galaxy, you've got to take all the mass, scrunch it down to a point-sized particle and assume it's there. And when you try to calculate the velocity of the star at the edge of the galaxy, it doesn't work. You can't use it that way. Now, there are other people. And the particle model as well has a model that uses mass distribution. It can work if you account for the mass distribution of the galaxy. They misuse it. They're absolutely convinced that the Newton's universal law is valid. They love the gravitational constant, and they end up having to invent dark matter. And it's not a law. Does gravity have to obey Newton's law? Or does it, gravity looks over Einstein's shoulder and says, oh, that's what I'm supposed to do. And what happens if gravity disobeys Newton or Einstein's law? Are there any consequences? Or can we put gravity in timeout? No, it just... Laws are just overstated. They're exaggerated. It's a word I really don't like. One scientist says, and this is the phrase part of the talk. I was listening to a Brazilian physicist over a teleconference quite a few years ago, and he said light obeys wave theory. How does light obey any man-made theory? It's impossible. That's a statement that should never be made. I typed in the chat room, no, light does its own thing, whatever that is, whatever light is, and however it does it, we can observe, we can measure, we can do all kinds of things, but it's doing its own thing. It's not going to obey your theory no matter what it is. This is scientific arrogance to make a statement like that, to think that you have an idea, you have a theory, you have an equation, and light better obey it. That's just arrogance taken to a limit. Well, does TPM have laws? TPM has principles, not laws. At least this is the word I like to use. Dave and I are writing a book called Principia Mathematica 2. Generally, we call Newton's book The Principia, but it has a subtitle. It has a subtitle, and I got the book right here. It has a subtitle. I know you can't read it, but it says The Principia, Mathematical Principles of Natural Philosophy. It's the subtitle states principles. But if you go to page 19 of the book, there's laws. Newton used the term law. Okay, I have a lot of respect for Newton, but not the use of the word law. Now, so now you got to talk about, well, what is a principle? Principle, I looked that up, is a fundamental truth. It's pretty strong. We'd like to think about it that way when we say, here's a fundamental idea and we think this is true. But in reality, it's a proposition. Proposition that serves as a foundation for a system of belief or behavior or a chain of reasoning. And in a development of the particle model that Dave and I have done, we start with principles and we use those principles to develop a chain of reasoning that leads us to understand the various parts of physics, the physical world. I've often said TPM suggests that the charge is not real. I can't mandate it. I can't say it's an absolute truth. I have no proof that the electron has no charge. I have no proof that it has charge. Charge is, to me, just an assigned name that gives us a way to talk about it and helps in descriptions if you agree with the plus and minus, charge, attraction, and repulsion. So I use the term suggest. That goes along with a proposition. TPM suggests that all motion is caused by a push. And we can take some of these statements and we could make them a law, but we don't do that. In my mind, I talk about it as a principle. People may argue that I shouldn't use that word either, but right now that's the choice I have. My name is Bob D. Hilster, and I am your particle model guru. If you have a question, ask Particle. That's me, not Quora. Quora.com, you can go online to Quora.com and ask them a question. They'll give you their answer. I read them all the time. I'm on their list. I love getting them because I've gotten ideas from them about making videos. But if you want to ask me a question, you can email me at particleguru@gmail.com. Thank you for your attention.